So question number 20 we did in the last class, the previous paper, like the previous question. So we are starting from here. This question says that complete the electronic configuration of for a bromine atom using the SPD notation. Can you tell me the proton number of bromine, Noor? What's the proton number for bromine? Proton number for bromine. I think so. Chlorine is 17 and bromine is, I don't know. Tell me. Yes.
35.
35 means that 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 3p, 3d10, school is school, public is school, public is school, Daud public is school. 4p, 4p5, 2, 2, 6, 2, 6, 2, 10, 5. So the total is 35. Am I right? Is this
Yeah.
35? Okay, then question number B. Species, then protons, neutrons. Bye. It's proton, proton means 35, neutron means 79 minus 35. That is equal to, I don't know, electrons are 35. And for this one, protons are 35, electrons are 36 because it has a minus one charge. And of course, 79 minus 81. It would be 81 minus 35 would be equal to the number of neutrons.
46.
Okay, very easy question. 46 for this and for 79 minus 35.
44.
44. Okay. A sample of bromine contained equal amounts of the two isotopes. Complete the mass spectrum. Or to show the peaks you would expect for Br2 positive. Okay. And from this sample of bromine gas, Br2 positive, we have the three possibilities. We may have this one. So they were saying bromine has two isotopes, 79, 81, 79, 79, 81, 81, 81, 79. We have the three possibilities. If you can see, if you are going to add 79 plus 79, so that would be equal to 158, I think so. It would be equal to 162. It would be equal to 160. Am I right?
Yes.
Then it would be at 162. It would be at 160. You know why I'm going to do this one? Why this is just like that? Because in this question, you need to know what should be the peak height for bromine. That's gonna 1 is to 2 is to 1. 1 is to 2 is to 1. And if you remember for the chlorine, it was 9 is to 6 is to 1. You need to memorize this. Okay, that's why I did this. It's 1 is to 2 is to 1. Calculate the number of bromine molecules in 2 grams of Br2. So the number of molecule would be equal to mass over mr. Okay, number of particles would be equal to multiplied by the Avogadro's constant, that is this. Mass is 2 and the mr of bromine, that would be equal to see the periodic table. What's the MR of atomic mass of
80.
bromine? 80 times 2 would be 160 multiplied by Avogadro's number. And then what's the answer?
7.5 into 10 to the power 21.
7.5 into 10 raised to the power 21. Okay.
Yes.
A sample of bromine gas occupied 200 centimeter cube at a temperature of 77 degrees Celsius. Okay. And a pressure of 1.51 times 10 to the power 5 Pascal. Calculate using the ideal gas equation. The amount in moles of bromine, the amount in moles of bromine molecules in this sample. Okay. So PV is equal to nRT. We have to calculate the mole, that is N is equal to PV over RT. P is pressure. Okay. P is the pressure. So the pressure is, you can say 1.51. Volume is 200 times 10 to the power centimeter cube into the meter cube. So 10 raised to the power minus 6. R is 8.31 times the temperature is 77 plus 273. That's the temperature. Okay. What's the answer?
1.04 into 10 to the power negative 1.
1.04
Into 10 to the power negative 1.
negative 1.
Sorry, negative 2.
Okay. Okay, magnesium is a metal in group 2 of the periodic table. It reacts with chlorine to form the salt magnesium chloride. Draw a dot and cross diagram for magnesium chloride. Since this is an ionic compound, you are not supposed to show the sharing of electron. Of course, we are supposed to show the transference of electron. So of course, we have two chlorine atoms and one magnesium. So, I would be writing first magnesium. After the donation of the two electrons, it would be just like that. 1, 2, 3, 4, 5, 6, 7. Then this is the eighth one from the magnesium. Okay, minus 1. Same for the other one. Simple. Okay, easy, easy.
Yes.
Magnesium conducts electricity when it is in the solid state. Magnesium chloride conducts electricity when it is molten or dissolved in water, but not when it is in the solid state. This is of 3 marks. What you would be writing in this answer? Yes, of course, magnesium, you can say that conducts electricity when it is in the solid state, because it's a metal. It's a metal. It has an electron, delocalized electron. But magnesium chloride would not be conducting electricity when it is solid, because there is no any free ion in magnesium chloride. Okay. So explain these observations. I would be writing that magnesium, that is Mg, is a metal as it has free delocalized electrons. Okay. And and in molten or aqueous state, ions are not free to move, would not conduct electricity. Okay. Simple, easy. Yep. Write the ionic equation including state symbols for this reaction. H plus, H plus, of course, magnesium oxide going to react with Mg2 plus, okay, and H2O. This is an ionic equation. Simple. State symbols. Do you know how I did this? How I got this answer? Should I show the working? Hmm? Should I show the working? Yep.
Yes.
Okay. So you are supposed to break down the you are supposed to break down the compound which is going to have aqueous state symbol. You know what I would be doing first? I would be doing MgO solid. It remain the same. It's solid. I have to break it down because this is aqueous. Aqueous. Again, I have to break it down. Then you have to cancel it out. The same thing. Okay. Calculate the minimum volume of 2 mole per decimeter cube hydrochloric acid needed to completely react with 2.545 grams of magnesium oxide. So they are asking the volume of 2 mole per decimeter cube. You need to first find out the moles of magnesium oxide because they have given you the mass. What's the molecular mass of magnesium oxide? Hmm? And then what's the answer of mole?
0.061.
Since the mole ratio is 2:1, then this is 1x. 0.06 times 2 would be equal to 0.12 mole of HCl. They are asking the volume. Concentration times volume. Mole is 0.12
0.12 into
divided by the concentration, that is 2. So the answer would be, so the answer would be, what's the answer? Yes,
0.06.
decimeter cube. Okay, 0.06 decimeter cube. A further method for making magnesium chloride is by reacting magnesium carbonate with dilute hydrochloric acid. Calculate the maximum mass of magnesium chloride that could be formed when 2.25 grams of magnesium carbonate is added to excess dilute hydrochloric acid. So they have given you the mass of magnesium carbonate, that is that you are supposed to magnesium chloride, that is this, and this is magnesium carbonate. Can you tell me the molecular masses of both? Yep.
MgCl2 is 95.2.
Then what is carbonate?
84.3.
So carbonate is 2.25 grams. This would be X. This is also one of the method that you can do without finding out the moles. But this method is only applicable if they have given you the mass and they are asking the mass. What's the answer? What's the answer?
2.5.
2.5 grams is your answer. Okay, simple. Explain why the reaction to make magnesium chloride from magnesium oxide has a higher atom economy than the reaction using magnesium carbonate. No calculation is required. No calculation is required. What do you think? It's of 2 marks. It's of 2 marks. Yes, you can see that why the reaction to make magnesium chloride from magnesium oxide has a higher atom economy. If I would be doing this equation in this manner, like MgO plus HCl would be giving us magnesium chloride and water. It has only two products. It has three products. Of course, what's the formula for the atom economy? The required mass divided by the total mass of the product multiplied by 100. So if you are going to divide it by the whole mass of the product, if the mass of the denominator, if the mass of the denominator increases, so the overall answer decreases. And so when you would be solving the atom economy with this equation, in this equation you have three products. So I can write that um, the reaction with magnesium oxide, okay, I can write that reaction with magnesium oxide, reaction with magnesium oxide, okay, having less number of products, less number of products, okay, or you can say the less number of waste products. So, so the molar mass of all the product is lower. Okay. So means that the denominator is lower. Okay. So of course I can say the atom economy, okay, the lower the denominator, okay, the lower the denominator, so I can say that the atom economy would be lower. It's very simple. It's very simple. Hmm? Okay. So I can say that they are saying atom economy is equal to the mass of magnesium chloride divided by the mass of product, that is MgCl2 plus water. And if you're going to solve by this equation, so it would be just like that. So for this, I would say that low atom economy, high atom economy, because lower molar mass, higher molar mass. Okay, it's very simple, very simple. The alkanes are a homologous series of saturated hydrocarbons. Draw the disparate formula of the three alkanes with the molecular formula C5H12. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Okay. These are isomers. I'm not gonna write hydrogens, so it's understood. Okay. You're supposed to write it down. Okay. We are short of time. That's why I'm not writing down. Simple. Give the systematic name of compound P. Compound P. So I told you we have different rules to give the systematic name, IUPAC name to this compound. So the rule says you have to select first the longest carbon chain. Okay, so this is the longest carbon chain, which is going to have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 carbon atoms, 1, 2, 3, 4, 5, 6 carbon atoms. And this is the branch, this is the branch. Okay, then you are supposed to give the number to the branch. Where is the branch? Okay, so I would say
2,
that
3 dimethylhexane.
2 comma 3. No, it's 2 comma 4. I think so. It's 2 comma
Yeah,
4.
sorry, 4. 2 comma 4.
It's 2 comma 4. Like 1, 2, it's 1, 2, 3, 4, 5, 6. 2 comma 4. Dimethyl hexane. Predict the molecular formula and boiling temperature of the straight chain alkane that has 5 carbon atoms in its molecule C5H12. What's the boiling temperature? The temperature is going to increase. The temperature is going to increase. Okay. The temperature is going to increase. Then you get to, you know the difference. What's the difference? What's the difference like that between these two compounds? So you got an idea after subtraction. So you can write that it would be 30 degrees Celsius.
38.
38, 30, 32, 28, 25. So you can write any, okay? But you are supposed to subtract it to get an idea, like what should be the range, okay? Alkanes undergo incomplete combustion when they burn in a limited supply of air. Write the equation for the incomplete combustion of propane to form carbon monoxide, carbon dioxide, and water. Okay, so I would say that propane is C3H8, monoxide, dioxide. Then we need to balance this equation. And also they are saying carbon, 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 carbon. Okay, so the carbon, carbon is balanced. Carbon, carbon is balanced. Hydrogen, we have 8 hydrogens, so I'm supposed to write 4. Now the oxygen becomes 4 ones are 4, 4, 4 plus 2, 6, 6 plus 1, 7. So 7 means that I'm supposed to write 7 by 2. This is the balanced chemical. Explain the toxicity. Explain the toxicity of carbon monoxide. Toxicity of carbon monoxide. You know, carbon monoxide, CO reacts with, it's an old concept, reacts with hemoglobin. Okay, reacts with hemoglobin and in the blood. Okay, and forms a compound which prevents blood to carry oxygen to the body. Propane reacts with chlorine. Write the two propagating steps to show how the C3H7Cl is formed. Curly arrows are not required. So means that C3H8 would be reacting with the chlorine radical. It would be forming C3 would be forming C3H7 and of course HCl, and then C3H7 dot would be reacting with the chlorine molecule. It would be forming C3H7Cl and again the Cl radical would be formed. Identify the different C3H7 molecules that are produced in this reaction. Okay, so identify the different C3H7 molecules that are produced in this reaction. Of course, we have 3 carbon atoms. Okay, we have 3 carbon atoms. So maybe the position of the chlorine should be different. Maybe the position of the chlorine should be different. It may be at the first carbon atom. It may be at the second carbon atom. So, so the products may be 1 chloropropane and 2 chloropropane. Okay. Give a reason why a mixture of C3H7Cl molecules is formed. Give a reason why this is going to be formed. You know what you would be writing? Because you can say that uh, we have a chlorine radical. Okay. We have a chlorine radical. You know what the chlorine radical does? The chlorine radical removes hydrogen. The chlorine radical remove hydrogen. Okay. Why a mixture of C3H7 Cl molecule is formed? Because chlorine radical has removed hydrogen. Okay. Or it can remove hydrogen from the first carbon, it can remove hydrogen from the second carbon, it can remove hydrogen from the, of course we have three carbon atoms, so I cannot say the third position. We have only two positions, the first position and the central and the second position, that's it. So this is of only one mark. I'm supposed to write the chlorine free radical. Okay. uh, Remove hydrogen, okay, from from first and the second carbon atom, second carbon atom, okay, can remove hydrogen from the first and the second carbon atom. So of course it would be forming this product C3H7Cl. It's understood. Give a reason why some hexane is formed in this reaction. Hexane, in the termination step when we are supposed to terminate the radicals, so of course the two radicals are going to react with each other. C3H7 dot is going to react with C3H7 dot and it would be forming C6H14. Of course, it's an hexane. A small amount of product with molar mass 113 grams per mole is formed. Reduce the structure and the name of a possible product with this molar mass. With this molar mass, you know what you would be doing? You would be doing? The structure of that product whose molecular mass should be 113 grams per mole. So you need to write like draw the structure of that product whose molecular mass should be 113. So you can write I think so the carbon atoms would be the same, of course. The carbon atoms would be the same. The chlorine should like the chlorines the position of the chlorine should be different, of course. So we have this one. Let's suppose we have this one. It's 1,2-dichloropropane. Noor, can you tell me the molecular mass of this compound? Is this 113?
No,
It's not 113.
the MR.
Yeah.
Yes, yes,
C3H1 2 3 4 5 6 and Cl2. Is this equal to 113?
yes.
So the structure is this and the name is this. Simple. Okay. Oh, give the names of the reagent W and catalyst X. So W means that alkene to alkane, alkene to alkane. Baby question. Very easy question. So the reagent is hydrogen. Catalyst is nickel. Draw the displayed formula of compound Y. They are going to oxidize. They are going to oxidize. They haven't mentioned the temperature, so I would be assuming that this is the room temperature. Okay, so I told you that whenever you have an alkene, if you are going to oxidize it, so it would be giving you, in the presence of an oxidizing agent, diol. Diol. Simple, simple. Okay. Draw the skeletal formula of the major product Z. Okay, okay. Major product means that you have to apply Markovnikov rule. Hannah, you have to apply the Markovnikov rule, which says that the negative species should be attached on that carbon, which is going to have the less number of hydrogen atoms. Of course, it should be this carbon. This carbon is going to have only one hydrogen, and this is going to have two hydrogen. So you know what I would be doing? Four carbon atoms. Four carbon atoms. Okay. One, two, three. Oh man, three carbon atoms. We have three carbon atoms. We have three carbon atoms, and at the second carbon, I have bromine. They are going to react with chlorine. Sorry, it's chlorine. This is your major product. The minor product would be this when the chlorine is over here. Okay. Complete the simplified mechanism. Okay. Complete the simplified mechanism. Okay. 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 This hydrogen is going to have partial positive charge. This is going to have partial negative. Then the double bond is going to attack. Then the double bond is going to attack on this hydrogen, of course. Okay. Then it would be just like that. Okay. This carbon is supposed to have a positive charge. Then this OH negative is going to attack on this positive charge. And you can see that this is going to be formed. Oh my god. Okay, okay, okay. I should do in the next step. I should do in the next step. Yep, like that. Predict the shape of the intermediate ion with reference to the positively charged carbon. Justify your answer. How many lone pairs and bond pairs it has? How many lone pairs and bond pairs it has? So, what you would be saying about that? Of course, it has three bond pairs, zero lone pair. Trigonal planar geometry. Okay, trigonal planar geometry. So, three bond pairs are there around central carbon. Okay. Draw a section of the polymer. Oh my God, it's very easy question. Section of polymer. You are supposed to convert the double bond into the single bond, showing two repeat units. One, one, then two repeat units. H, H, CH3, then CH3, H, H, CH3, then this is CH3. Double bond is converted into the single bond. These are the two repeat units. This is the first one. This is the second one. So 2 marks only. That's all for this. That's all for this paper. Okay, Ji. Thank you.